Hello students. So now being able to understand what basically are the equations of motion that govern any particular particle. In this particular part, we'll try to understand about the motion of a particle. Any arbitrary particle, when subjected to any force or without any force, what exactly are the equations that are going to be governing its motion. We'll also try to understand what are the basic prerequisites, that is some concepts of differential and integral calculus that will be needed in this particular thing, and from there we'll try to understand about the equations of motion. We'll also try to understand using some graphs as to what does any particular motion, that is velocity time graph, the acceleration time graph, what do those things tell us more about the particle. Now continuing on, what we are going to discuss today is basically the understanding about how to determine the motion of a particle. So for that, the first thing that we need to understand is what exactly does motion stand for. Motion basically represents as to how the particle is moving as a function of time, how its position is changing with respect to the time. So if I'm talking about the motion of a particle, the motion of a particle is known if the position is known for all instants of time. So if we know about the position, that as to how the position is changing with time, that means we know the position at all instants of time, right? Taking it further, what we need to understand is this. When we talk about the motion, typically conditions of motion are specified as to what is the type of acceleration that is experienced by the particle, right? Therefore, the determination of velocity, so when we know how much is the acceleration of a particle, that is going to tell us as to how much is going to be the velocity of that particular particle. And therefore, integrating about it, so integrating the velocity, integrating the acceleration will give us the velocity, further integration will give us the position as a function of time, obviously. So therefore, what we can say that acceleration can be differentiated into three basic parts, that is acceleration as a function of time, acceleration as a function of displacement, and acceleration as a function of velocity. Let's see how and what the difference exactly is. So if I talk about the first one, so when I talk about the first one, basically I understand that acceleration is a function of time t. So acceleration, as I know, the velocity is nothing but change in velocity is nothing but acceleration. So dv by dt gives you the acceleration, which is basically a function of time. So if I just rearrange it, so that gives me the dv can be written as ft into dt, right? And therefore, if I integrate from, let's say, the initial velocity v0 to some final velocity as a function of time t, dv, so this will give me integration from 0 to t of ft dt. So if I integrate this, so this will give me vt minus v0, which will be equals to ft dt, right? In a similar manner, the velocity at any instant of time can be written as a function of the change in displacement with time. So in a similar way, I can say dx can be given by vt into dt just by cross multiplication. Again, integrating from x0 to some function xt, what will we get? We'll say that this can be given by an integration from 0 to t vt dt, or on integrating this is nothing but x raised to the power 0, you can say. So if you integrate, so I have skipped a step, obviously that should be clear. So I can say x of t minus x0 can be written as just 0 to t vt dt. For that, we need to know what is the value of vt, or if you are starting from acceleration, you need to know what exactly is the function ft, right? Okay, so this is how the acceleration varies as a function of time. In a similar way, if you want to say that how the acceleration varies as a function of x, so to understand about that, what will we say? So if I say a equals to f of x, now we know that v is equals to dx by dt. So if I just do a cross multiplication, so dt goes up and v comes down, so dt comes out to be equals to dx by v. Further, acceleration is equals to dv by dt. So what I can say, since acceleration is equals to dv over dt, so this can simply be written as dv over dx into dx by dt. But we know that dx by dt is nothing but v, so this can simply be given by v into dv by dx. So that is what we have out here. So acceleration is equals to v into dv by dx, which is nothing but a function of x. Therefore, if I just do a cross multiplication here, so v dv will be equals to fx into dx, and therefore if I integrate it, so I'll get v0 to v dv, which is equals to an integration from x0 to x of fx dx. On integrating this, obviously the power is going to go up by 1, and you'll have the net result, whatever goes up is also going to come down. So you'll get half Vx square minus half V naught square. So this can simply be given by Fx dx. Finally, if I have to talk about the acceleration being a function of velocity, so if I say that the acceleration is a function of velocity, I can simply write it like this. I know that acceleration is equal to the change in velocity with time, which is a function of velocity. So just doing a cross multiplication will give me dv divided by f of v, which is equal to dt. So if I have to just integrate this, so I will be integrating v naught to v dv divided by fv dt. I need to know the function as to how the acceleration is varying as a function of the velocity. Further, on the right hand side, if you just integrate, so this is nothing but t raised to the power 0. So this will give you t going from 0 to t, and therefore this is going to give you the value t, which you get out here. In a similar manner, as we know, acceleration can be given by v into dv by dx. So let me revisit that. I know that acceleration is equal to dv over dt. So this can be written as dv over dx into dx over dt. But dx over dt is nothing but the velocity v. So this gives me v into dv by dx. Right? So v into dv by dx is equal to the acceleration a. So if I just do a cross multiplication, I'll get dx, which will be equal to v dv divided by the function of v. As a result, if I just integrate this, I'm just putting up an integration on both sides. This is what will I get. On the left hand side, this gives me xt minus x naught. On the right hand side, I'll get something like this. So this is what we get. This is how the displacement and the velocity can be written as functions of the time t, and so on. Hopefully this made sense. Now let's try to do it in the form of an example. So what we have here is the following. So in this case, let's say I have a ball is tossed with 10 meter per second vertical velocity from a window 20 meter high. So let's say it is being tossed from here in a upward direction. You need to determine the velocity and elevation above the ground at a time t, highest elevation that is reached by the ball and the corresponding time when ball will hit the ground and the corresponding velocity. So let's try to solve this. So if we try to solve this, what will we get? First, these are the steps that we need to follow. If you need to follow this, but we say that integration form is where the acceleration is given. So you integrate twice to get the value of the function of vt, and followed by that is going to be y of t. Then if you solve for t at which the velocity equals 0, that is at the highest point the final velocity is going to be equal to 0. That's the reason that's the highest point. Using that, you can find out what is the maximum height. Then you solve for time t at which the altitude equals 0, and therefore you find out the corresponding velocity. That is, when the altitude becomes 0, what does that mean? It means that the body comes down. So obviously it is going to tell you as to how much is the velocity with which it is going to come down. You have to equate the potential energy and the kinetic energy. So once you know that, that will give you the corresponding velocity. So let's try to solve this. So what we have here is the following. So we have dv by dt, which is the acceleration that is given to us. So if I integrate this, because acceleration is given to be a constant, so here if I just integrate, so I'll get the function of velocity. So vt minus v naught, that will come out to be equals to 9.81. Now you may say that why is it 9.81? The reason it is minus 9.81 is because of the simple reason that the body is coming down. So you need to choose your direction, because these are vector quantities. So when you choose a direction that the body is coming down, so that's the reason you have a negative sign out here. So you have a negative 9.81 into t. Therefore, if you just integrate, you know that the initial value of velocity in the upward direction is 10. So obviously this is the function of velocity that you will get. So at any instant of time, this is how the velocity is going to look like. Now I need to integrate it again. So how do you integrate? Because the velocity is given to you. So velocity can be given by the change in time, change with time. So dy by dt, which will be equal to the velocity v that you are given, which is nothing but, if we just neglect the units just for brevity, so we can get 10 minus 9.81 into t. Therefore, if I have to integrate this, so what will I get? I'll get integration from y naught to y. Obviously, we are finding out the displacement. So if I integrate it over here, so I'll get yt minus y naught, which will be equal to 10 into t minus half into 9.81 t square. Y naught is already given that you're starting from that particular height. So that's the reason you have 20 meters. So 20 plus 10 minus 4.905, that's 9.81 by 2. So that's the reason you have, this is the expression of y, this is the expression of v. Now once you know about this, you can find it out. So at the highest point, the velocity is going to be 0. So if you put the velocity to be 0, so that will give you the expression of time. So the time comes out to be equals to 1.019 seconds. And in a similar manner, if you want to solve for the time taken, or for basically when the displacement is going to be 0. So displacement is going to be 0 when the particle comes down. As a result, what will we get? We'll get, means you need to just put this to 0. So, or first finding out what is the vertical height reached. So when time equals to this, how much is the vertical height reached? The vertical height that is reached is coming out to be this much. And in a similar manner, when you put y equals to 0, so as you can see, this is a quadratic equation. So on solving this, you'll get two values, because it's a quadratic equation, so you will get negative value and a positive value. Obviously the negative time does not make sense because time is always in forward direction. So this is the time it's going to take for the body to come back to ground, right? Hopefully this makes sense. So students, we learned about the motion of a particle in this particular topic. Now we'll take it further and try to understand about the rectilinear motion, rectilinear uniform motion, and then rectilinear uniformly accelerated motion. The difference between the two. When it is uniform motion, in that case there is no external object, external force acting on the particle, and when there is an external force acting on the particle, in that case it's going to be rectilinear uniformly accelerated motion. It's going to be accelerated uniformly, means there is going to be a constant acceleration, not a variable amount of acceleration. Taking that further into account, we'll try to understand about what are the different expressions of velocity with time, displacement with time expressions. So that we are going to understand in our next part. Thank you.